Hello and welcome. This is Alex from Black Sheep IT Consulting with a quick update on one of the features we included in devpops recently. Let me just show you the feature. So there's the new devpops menu. You can also use the old one. And in demos, we have Surprise Me. And well, that comes as a surprise as it reads the applets within the views, takes the data and reformats it, producing a new tab with HTML that can be zoomed in. It's responsive and can of course be printed. Now, word of warning here, this is not a replacement for any of your sophisticated reporting tools. It's just taking what's currently in the view and, well, re-renders it using primitive HTML. So let's say it's a replacement or successor for the defunct Quick Print, which worked quite in the same way. So we added a few tweaks here, and in the next few minutes, I would like to give you an overview how to extend the functionality of that to not only include what you see on the screen, but also include, for example, if the applet has more than 10 records or the business component query behind it is more than 10 records big, then you can retrieve all of the data. So let's see a few examples. So this is a simple detail view with a form applet on top and a list applet below. And as you can see, it deals with form applets and list applets. It doesn't deal with any of the more sophisticated applets like charts, etc. But you can work out how to do this. Let's go to, for this customer, let's go to another view like this one. This is the account summary view with the installed assets, billing items, quotes, orders. So it's 7 applets. And hierarchical applets here. You notice when you do a print screen or something like that, when you print this view, that, well, let's try it. Let's try printing this view. Okay, comes out like expected, but the data is truncated and only the data shown on the view is there. So it's not really perfect for printing. So now let's try the Surprise Me demo. And it reads all the applets, form and list applets, and it does not truncate. It takes care not to truncate any data. So a nice printable view here. So if you put that on a printer, PDF or real printer, then it would look like this, fits on one page and you have all the data, which is of course much nicer than printing the view itself. So that's what the demo is all about. Show you that you can produce Open UI compatible code that does something like this. Let's take it to the test one more time. Let's do an EIM table report. Now again, it's not replacing your reporting tool. Well, let's find here, let's say the EIM account table. And well, that's just unfortunate CSS here, but the attribute mapping, let's select a really big attribute mapping, sorgx, then that has 16 plus records. Now 10 are shown. So let's see how the tool works with that. Let's use that menu. Well, not too bad. So it shows the header record, the table mapping shows which one is selected, and for the selected one shows well, only 10 records, because that's what we can get out of the presentation model of this applet. So that's, of course, a limitation of the demo. And, well, we'll see how we can overcome it, theoretically at least, or practically. But that's, of course, a decision you have to take, because there might be security implications with the solution presented. Another aspect is using, of course, the user side labeling of the applet. So default mapping column name prefix is is a display name for list column, and it's not the field name of the business component. And also the order, the sort order, the column order, and the query. So let's see how this works out. So if we change, let's say let's run a query here. So we're only interested in the sorg_ext mapping. And we do columns displayed and remove the explicit mapping flag, let's say. Okay, that leaves only those columns. And in the attribute mapping, let's rearrange some columns using columns displayed. We want the comments to be next to the name, let's say. Okay. So, of course, the UI follows suit, but let's see how the printout now looks like, or the pop-out, as I call it. Okay, the filter, it only shows the record currently in the applet. It doesn't have that flag, and the comment is now second column. So it really follows what the user sets in terms of queries, columns displayed, etc. So let's dive a little bit into the code. So if you look into devpops.js and look for example, the label surprise me, you will find the menu item, which triggers a simple function, bcrm pop-out view. Now that view definition or that function definition is in the same file. So that's the function that runs. It's a intentionally dumb function. So it's not a replacement for a publisher. It's intentionally left dumb, just as an educational example, which all of devpops is. So what does this function do? Let's go through all of the lines of code here for the sake of education. So we establish a variable called all, which is using jQuery, and the selector is any ID which starts with s_a. So effectively all the applet containers in the current view. We also get the applet map, and you wonder why. Probably why do both? Why do the jQuery selector and the applet map? But you will see this because we want an array of applets, which is the wholesome applet map, or WAM as I call it. And that array we produce down there. Then we have the PM, control set, control unused variable here, another helper array, and the BCRM utilities to call some utility function in the same file. So now we go through the result of all the applet containers, which might include some applets which are hidden, which is the interesting part here. So we go through each of these applets. That's an iteration loop. And now we compare that to the applet map. Now we go to the applet map, retrieve the presentation model for the applet map. Applet, get the full ID, and match up the ID. So that is an applet represented in the applet map. But because we go through the all variable, we have an array of applets as it appears in the view, because the applet map is not sorted. And this is now a sorted array. The first applet, the top applet is the first, and so forth. So we push it to the wholesome applet map. So that's a little trickier to get the applet in the order they appear in the view. Not counting for applets that only consume half of the screen or so, but we're fine. Okay, now we open a new window already. So empty URL. So that's an empty window. So we have to write to that window all the time. There's a new date variable to display the date in the new window. And we generate a bunch of containers using jQuery, simple diffs, one acting as the header, one getting the document title and date, formatted date, and there are two buttons there. So I The print button we have already seen. And we have a toggle edit mode. I haven't demonstrated this, but it switches the document to edit mode, so you can actually change the values in there, which is pretty scary. You can do that. And then we pull all of this together so that we created our header. We apply some inline CSS because devpops doesn't use a custom style sheet. It's all inline. You should put this in a real style sheet, of course. And we do the document write, neat little function right to that W variable. So we basically set the HTML we just produced there. So it's an empty shell, more or less. Now we don't have any data yet. Now we go through that wholesome applet list. So for each of the applets we identified, we get the applet type using a utility, devpops utility function. And if it happens to be a form applet, we get the PM, we get the control set, and we produce a diff for the applet container. So CT is the container. And we use grid display, so CSS grid, inside that container because it's a form applet, and we set 4 columns auto display for the grid. So look up CSS grid for more details on that. So that is a easy responsive 4-column style because we need to regenerate the HTML of the applet using grid and flex layout. So for each control, we create another field container, more or less. And there's a little bit of checking here, and we generate a label using the display name of the control, and we generate a field value. And we use the PM execute method to get the real formatted field value there. And then we append all that together, and we push it to the array we have. So that's the applet array, the output array that actually receives the form applet in this case. So form applets are regenerated using simple container techniques, reading the labels and the field values. So because it's read-only, we don't need to worry about inputs or text areas too much. So for list applets, we need a HTML table. That's the best way of displaying list data. So if the applet type is list, we actually clone the applet. So that's the list clone, list applet clone. So we don't worry about the original applet. We get the presentation model, and we get the business component name. We get the current selected record. You know, we want to highlight that. We get the applet title, and we get the row counter of the applet. And now we create a container and a header. So that container we'll use later on as we append that. So now we need the HTML table, basically. And there's a function here, bcrm get table from list PM. So a special function I created to literally convert the PM record set into an HTML table. So it's good to have that as a separate function. So let's jump there. That's actually in post load. So this function calls another function, get the display record set. Now get the display record set gets the controls and record set of the PM. There is a full record set example. I'm coming to this later. It has an exclusion array of fields that we are not interested in. And what this does is basically go through the record set. So for each record, basically identify the control and create a temporary entry with the display name. So instead of the field name, we use the display name. So it literally translates the field name of the field, like, opportunity name, into the display name, and pushes that to the RS array. So that's the record set it puts out. So it creates a record set with the display names instead of the field names. That's what this function does. So now we have a record set with the display names. And now we obviously create a table with a header. So using the first row, we create that table header, the column names, and then the table body. And so that means for each of the records, we create a table row, and we create a table definition for each field, and we append that to the table row and append that to the table body. And then we append all of this together and return a nice HTML table representing the list applet, now with the display names on the first row. Okay, so that is the HTML table that we now have, and we want to display in that other tab. So here's a bit I leave out, so that's using the record count in case there is a record count available. More on that later. Now we set the counter text, we do some CSS, and we append to the container, we append the big container, the container we have created. Now there's a little bit of CSS here to organize the data in the table, make it readable, highlighting the selected record, and pushing all of that to the major array of applets. And now, once this array is complete, we iterate it. There's a little bit of CSS added, so for each applet, and we literally write each of the applet containers that we created to the waiting tab in the document. Notice that this is synchronous, so the user has to wait until we have done all this. And for good measure, we generate a bookmark. So this is experimental, but we can generate a URL that serves as a bookmark where we have retrieved that. The bookmark is displayed on the bottom. And so there's the bookmark, and we have some CSS that we inject to allow for better printing. So we inject that literally in the header of the new tab document, and we set the document title to the current document title in the Siebel application. Okay, so that's the code walkthrough. So in summary, we go through each applet in the order they appear in the view. For each, if it's a form applet, we regenerate the HTML. If it's a list applet, we generate an HTML table, and we format it a little bit and add some icing on the cake, and then we display that on the screen. So let's see it again in action. So there's this EIM tables view I've been before. Let's close all these tabs. Let's just run it one more time. Okay, so took the form applet and created that simple. So is it responsive? Yes, because of grid. You see the applet is more or less responsive. And the list applet, first list applet, the second list applet. And there's the bookmark. Of course, clicking the bookmark in this browser tab would just yield a problem here. So let's try logging out of the application. Let's see if the bookmark works. If you have multi-tab enabled, this would likely work. So let's open a new tab, log in. It should take us there. Yeah, not too bad. Took us to the view and record represented, primary record only. But not not bad for educational demo. So you can do a lot of things. And the two buttons I mentioned, we already seen the print button in action, and there's an edit button which sets the document edit mode. Also clearly sets the header to red, and you can remove stuff. For example, you don't want that time here. Yes, you can type here and you can actually change the data. So you can type and remove stuff. So, for example, I can remove contents of tables and stuff like that. And now when you print it, the header is red. So you see it has been tampered with. Of course, that's just purely to show off what you can do with modern browsers. It's quite impressive to have an editable report that you can then print and still see it has been edited. Of course, if you press F12, you can change the color back and all of that. All right, let's go back to that post-load code where we get that display record set. So we have a special function that returns the record set with the display names of the columns. And that uses the record set, so RD, record definitions or whatever, get the record set from the PM. Now we know, having worked with Open UI for so long, the PM always includes the records that the applet currently shows. So maximum 10, or if you're in more mode, maximum 20 records. But definitely not the entire query set if it's more than 10 or 20 record. So I've been experimenting with a function get the full record set, which requires a custom business service. So if you read that here, it works with any custom business service that is capable of returning the full record set for the current applet. So I happen to have this business service, but it's not part of devpops due to the severe security implications that business service would have. Anybody who would know how to call a business service could, well, fetch a lot of data. So you must implement that business service yourself. I'm not showing any code here. So there's a function which is capable of taking the PM and getting the full record set. Now if I uncomment that, I'm essentially overwriting the RD variable. So my record set is now the full record set. So I've been reloading the code here, be reloading the browser, so it uses now the full record set function. Let's select the sRGEXT, and this one has 16 plus. Let's see how many there are. Record count, so it's 191 records, clearly with only 10, the first 10 visible. Now let's try and, well, now it says nine records here, the sRGEXT is selected, and we have 191 records. So the business service, of course, is behind that is custom written and not available of devpops. But you have a full list of records. Now this looks like a really usable EIM table report, for example. So let's see that function here as it is in devpops publicly, but the custom business service it calls is not. Again, you have to write that yourself. So let's look for that function. So it's included in the post-load override. And so it assumes you have that business service. So we have that exclusion field list. We have the record set of the current PM. We have the current selection. We have the business component name. And we create a field list. Now that business service that I wrote requires a list of fields to query. And the list of fields is what is shown on the screen. So on the selected record, just easier. So there's a new property set here, an empty property set. And field list is a property set as well. Now for each field in the current selected record of the record set, could be anyone. We just exclude the exclusion list, and if the field is not in the exclusion list, we set it as a property in that field list property set. Okay, so that's the field list property set. Again, the business service code will pick that up. Then we use the BCRM invoke service method function provided with devpops, which can call any business service. So you can specify the service, the method, and the inputs. And the inputs is we need the current business component and run query to true. So that function, of course, that get active BC data function has to be implemented or similar. And it expects a field list, and the invoke service method can only treat property sets if they are encoded as string. Easy enough with the property set function here, which is provided by the Open UI API. So that would run, I will actually put the output of the business service here, active BC data. So you can see we get the result set out of that. There's a V property, which is the entire output property set as a string. So we can decode it from string. So if you have a property set representation as a string in OpenUI, it's fairly easy to encode and decode this to and from strings. We also get the record count, create a storage name using the BC name underscore count, and set the record count in the session storage, where the other code, the other function can pick it up. So we're using session storage here as a temporary place to hold those record counts for each business component. Then we get a child property set, the object data, which is the actual record set retrieved by that custom business service. And we get the child count, and then for each child, we get the child record. We get the first property of the record, and then we do a while loop and store the property. Prop is the name of the first property, so we create a empty record object, and that first field in the record object gets the value of the property. So the record set returned is field, business component field name, and the value of the field for each record retrieved by the query. And then we do a next property, and we do this while the property is not null, which would be returned by next property if it reaches the last property. So each property in that record property set. And once we're finished with that loop, we have one record we can push to the full RS array that's waiting to receive it. This is unordered in terms of columns, so we go through the full record set we have just retrieved again, and we basically reordered the fields into a temporary array. Reorder the columns, sorry, so they represent the column order in the real record set, because the real record set always has the correct column order. So that's just a rearrangement here, and we return that full RS, overwriting this. So instead of 10 records, it now has 191, or however many records you have in your current query. So that's really the business service is querying the active business object, and it gets the current query of the current business component. So it has to run in the context of the session, more or less. So that's a trick, and devpops, as you find it on GitHub, will in a future version, so at the recording time, this is not public, we'll have that commented out, so it uses just the record set available in the PM. If you happen to have a custom business service that retrieves more, you can spice this up. So with a last glimpse at one of these few pop-outs in devpops, Yeah, I say thank you for watching. Take care and bye-bye.